Hi everyone, I am TigerHawk3, and today we will look at Python's statistics module in the standard library. So let's go. Start Python, and we're going to import statistics. Okay. Not a very long module, but there are some handy things. Let's start by making a data set of data, and it will be about 70, 85, 85, 100, 105, 110, 115, 130, 145. Sure. Looks great. Let's start with mean. Statistics, spelled that wrong, dot mean of data. 105. The statistics.mean function is the arithmetic mean, which means, what does that mean? That's the average, generally speaking, is the word for it. And that's the sum of all of the elements divided by how many elements there are, which you can also do without importing statistics. Sum of data over len of data, and that's 105. How about median? Median is different from the mean in that it is the actual value in the data that happens to be closest to the middle, whatever that value would be. So for example, the mean of the number of dogs per household in America could be like 0.9 or 1.5. I don't know what it actually is, but it's not a whole number, and dogs don't work like that. Dogs are integers. So you might say that the median number of dogs is 1 or 2, somewhere around there. But let's do statistics dot median of data. That's also 105, because it's closest to the middle, apparently, and it's an actual number. Notice how it's the integer 105 rather than a floating point number derived from calculation. Here, I mean. So 105, the integer, is one of the elements in the list, in the data set. There's median low. I don't know what that means. Also 105. High, also 105. Maybe this is mean. Yes, okay, median. When the number of data points is odd, the middle data point is returned. When the number of data points is even, the median is interpolated by taking the average of the two middle values. Okay. The low median is always a member of the data set when the number of data points is odd. Bugs flying around everywhere. When the number of data points is odd, the middle value is returned. What is the difference? Oh, when it is even. So here's the difference. With the regular median, if there's an even number of data points, it can't really pick the middle one. Bugs, I tell you. No, die. Jeez. Violence on the stream. Anti-insect violence. Alright. Fantastic. The problem with bugs is that I'm now using a magic potion, meaning hand sanitizer. It's great stuff, because you don't have to mess up your hands with hot water. So, bugs are attracted to warmth and light, and what do you think monitors have? Create a lot of heat. I get bugs orbiting my monitors at night. It can be really annoying. Anyway, so when you have an even number of data points, the regular median function will get the mean of those two. So if we had, if there was another value, say 104 in here, it would be like, well, it's somewhere in the middle of that, and it would give us 104.5. But that number is not actually in the dataset. With median low, it's very similar to median, only it would have picked 104 if we had that in there, and median high is picks the higher one. Pretty simple. Median grouped. Return the median of grouped continuous data, calculated as the 50th percentile using interpolation. If it's empty, statistics errors would raise. Let's see what that does. Statistics median grouped. Also 105. Okay, the median and the mean are all the same number for this data set. Very tidy data set I created. That's okay. But it's the median of grouped continuous data. I don't know what continuous data means. Calculated as the 50th percentile with interpolation. I don't really understand that. I don't understand. Statistics. Not my area of expertise. Mode. The most common. I don't know if this will work, because I have one of each. It will. It just, oh, no, I had two 85s. That's good. Good planning on my part. Most typical value, and is a robust measure of central location. Usually in normally distributed datasets, you have what's called a bell curve, because when you make a little graph of each potential result on the x-axis and how many instances of that result you got on the y-axis, you get a bell shape. For example, grades in school. So the most common score on a test is probably in the middle-ish. Assumes discrete data and returns a single value. If there isn't exactly one most common value, it raises an error. I wonder if it works on a string. It does. Let's see what happens if there's no mode. Kablooey! Found 3 equally common values. Useful. Wow, it actually... I don't know what the point of that is. Like... I mean, it's already... This doesn't need to be in the traceback. This thing. That's the error it's raising, I guess. So it's going to tell me that it's raising an error, and then it's going to show me this string that it created. See, they have no unique mode, found %d, and then we interpolate the length of the table. This many equally common values. So, kind of funny, but that's okay. P, stdev, population standard deviation. PSTDED. Return the population standard deviation, which is the square root of the population variance. And the standard deviation of this is 22. The numbers that I entered above were kind of based on rather than IQ scores, just kind of made up. And it so happens that IQ is normally distributed, and the standard deviation is 15, and the average is 100. Those are kind of by definition, so it's not like you can't really have a whole bunch of people in a population way above or below 100. It's no matter how hard we try, it's always going to be an average of 100. Now the meaning of that 100 may change, but it is the average by definition. So whenever it changes, all these numbers move around. P variance. This much. That's the population variance. Great. A large variance indicates that the data is spread out. I think they mean indicates that the data are spread out. A small variance indicates it is clustered closely around the mean. So let's do a different data set. How about 444,556? Much smaller. Now let's add 20. That greatly increases the variance. Cool. On statistics functions that operate on numbers, like the mean and such, it accepts integers, floating point numbers, decimal objects, and fraction objects, which we have gone over in previous streams. How convenient. Just not attempt to verify. There's an optional argument of mu, which defaults to none, and if you don't pass in a mu, which is the mean of the data set you're passing in, it'll automatically calculate it for you. So maybe if you have a really gigantic data set that you have already calculated the mean for, you don't want it to do it again, you can save it and pass it in. How nice. If you have already calculated the mean of your data, you can pass it as the optional second argument mu to avoid recalculation. That's what I just said. Thanks, documentation. That's good. Good thing to mention. Population standard deviation and the sample standard deviation. So this is the population standard deviation, and this is for a sample. I don't know quite why they're different. The square root of the sample variance. And yet this is the square root of the population variance, the square root of the sample variance. I don't really know why those are different. Sample variance, measure of the variability, etc. Why is it different? Why is it different? To calculate the variance from the entire population, see p-variance. Yes, I noticed. I don't actually know what this is doing. Population versus sample. I don't know. That is pretty much the whole thing. Might as well show you this. 550 instead of 488 and a ninth. No, an eighth. 8/9. Sorry. That is a short module. As the description says, some easy to explain things like the mean, which is sum over len. Actually, I can also emulate mode. If we import collections, and I scroll down, collections.counter with data dot most common 85 with 2 of them, and sure enough, the mode is 85. So here we just made a counter object that counts everything up and finds the most common ones, or actually sorts them by their frequency, and finds the first one. So we could also do max key equals lambda x1 I'm trying to one-line it because I feel like it. So I really just want the maximum of my data set, and that being based on how many there are. So it's going to be something dot items something for number in set data. Number and quant, which is, no, I have to calculate that, which would be data dot count number. This expression became a little too long for this console window. I think that's good though. I can press enter and see what happens. 85.2, great. So I'm gonna actually do this. And then maybe this much. Great. So that is what that is doing. So this is nonsense that you should not do, basically. You could import statistics and simply tell it to get the mode. Or you can create a counter object with the collections.counter and count them up and tell it to get the most common, or you can do it yourself. And what I did here is kind of, if we start from the middle and kind of expand outward to see what I'm doing, we got data, that's our data set, and then we pass that to the set constructor to find only the unique values. And then we went through each of these unique values. So we have, so it means these two instances of 85 turned into only one. And now we're going to make a dictionary out of these, which is the number. See, for number in set, we turn that into a set to get the duplicates out, and then we go through this set that we created, and we use that as we use each element as a key with the value of how many of those keys there are in our original data set, data.countNumber. And the reason we change this to a set is so we don't have to count repeated elements a repeated number of times. So 85, for example, which appears more than once in data, will only be counted once. I mean, it'll show up as 2, but we don't have to. The naive way, basically, is we go through each element in our sequence or container, and for each one, we count how many there are. So the first time we see 85, we're going to go, okay, we're going to count how many 85s there are. There are 2 of them. And then we continue on, and there's another 85. So we take the time to count them again, and find that there are still 2 of them. It's quite popular to make a set in this sort of situation to avoid counting repeated elements a repeated number of times. You don't want to do that. What if there were many? What if it was a very large list with lots of repeated elements? Not great. This way, we only have to count the number of times equal to how many unique items there are. I hope that's clear. There's no one in chat saying it's unclear, but I think that's just because there's no one in chat and no one watching. That's okay. You will see this maybe later when the video is archived, and then if it doesn't make sense, you can post a comment. And also click like and subscribe. Do all those things. And then tell your friends to watch. That is. What else can I emulate? Median, I think that's going to be it. What will there be tomorrow? A game. Something. I don't know. Maybe League of Legends? I think I did that yesterday. But, that's most likely. I don't know. But it will be amazing and fascinating and extremely entertaining, and whatever I do, you should like it as well, and comment on it, and subscribe if you haven't already. I don't know how many times it's okay to say like, comment, subscribe in one video, but I highly encourage you to do so. Just a reminder, don't do this, and also don't do that. Do this. See how much shorter it is? Don't reinvent the wheel, because chances are it won't be very good when you do it again, because the people who invented it the first time have spent all this time refining it and making it a lot better. So you're basically throwing all their work away and saying, let's see what I can do with your beta version, alpha build of whatever you're doing. Meanwhile, theirs is tested and robust, most likely. That's it for today. So thanks for watching my stream, and I will see you next time. Have a good one.